Hi, this is Paul again. Now we'll take a look at lesson 10. On this lesson, we're going to focus on the golden ratio rectangles that make the icosa. In lesson 7, I showed the icosa sitting in the dodeca in a really nice layout. You can see that two edges of the dodeca line up perfectly with two edges of the golden ratio rectangle. I've decided to keep this orientation as a really good orientation. But from now on, we're going to start focusing on zDNA and bDNA. So I'm going to rotate this to a horizontal position. So we'll hide everything except the dodeca and the rectangle. And now we'll change the rectangle color to red, and we can also hide the dodeca. I'm going to give you some dimensions for this golden ratio rectangle. So I think I'll give you a diagonal as well. Now the two sides of this rectangle are perfectly golden ratio. And if you check the phi calculator on the web for 1200, you'll get these figures. And if you put the lengths A and B into the Pythagoras calculator, that'll give you the diagonal and also the angle. Now for those that like to follow my lessons, I'm trying to give you all the dimensions as I go along. I hope the numbers I show are correct, but sometimes it's easy to make a mistake. Okay, so now we'll go back to the bare rectangle once again. And we'll put this scene in the camera view again. Now what I'm going to do, I'm going to rotate a copy of the red and change it to green and rotate it in a 90 degrees axis and another 90 degrees axis. Do it just like I'm showing. Another copy of the red and change it to blue and rotate it 90 as shown. And now we'll rotate this in another 90 degree axis as shown. I have found by using this method with no decimal points in the rotation, we can get a pretty accurate icosahedron when we join the vertices up as shown. So now we'll go back to the front view again and we'll bring back the white size 6 dodeca. Now this is a special view and I'm going to call it the Platonic order blackboard view. What is important about this view is that two edges of the dodeca and two edges of the icosa will line up on the same plane. I'll add another rectangle on the dodeca edges for you to see this. We have all the essential measurements to fill in the rest. It could be a nice little exercise for somebody. Okay, now we can leave the blackboard view. Now we'll stay in the same plane but rotate to the vector view. Now these rectangles are very important because you can show two diagonals. So now I'll add another diagonal, and this is the green and cyan vector. These two vectors are part of the 369 arrangement, so I think we better get the angles. So we'll just show that rectangle and get some dimensions. Okay, we'll start by showing you a right angle triangle with A, B and C. First we know A. This is a dodeca edge, so it's 600 times 5. And we also know C, which is the diagonal of the cube, so it'll be root 3 times 600. Now we can show the rest with the Pythagoras calculator. The angle B between the two vectors is a very important angle. Now we'll go back to the scene with the dodeca and icosa again. Now we'll hide everything except the sloping rectangle and the icosa and the center red and yellow vector. I think I'll hide the icosa as well because what I want to show you is the length of A1 and the length of B1 on the golden ratio rectangle. We know the top half of the red and yellow vector is twice root 3. And we know the hypotenuse C is half the diagonal. And we also know the slope angle A. So now we're in business. We can find A1 and B1. So using the trig calculator, we found B1. And by taking B1 from the full length, now we know A1. Now when these results are double checked in a phi calculator, you will find that these are perfect Golden ratio. Isn't that something? Okay, I think we'll call this lesson a day because there's more stuff to show, but I think we've got enough in this lesson. I realize there's very few people in the world that likes 3D geometry. So those that like 3D geometry, I hope you download my work. This brings us to the end of lesson 10. So this is Paul saying thank you very much for watching.